In this video, we are going to discuss the broad categorizations for waves that we encounter in daily life. For example, this is an ocean wave. So it contains matter, it contains water, and the disturbance caused by this wave, the disturbance caused in the medium of water, is being carried along through the medium. This is a representation of electromagnetic waves, or the kind of signal that propagates inside a wire. So what is changing here? Here, the values of electrical or magnetic fields are changing throughout a given medium or a conductor. So we understand that a wave is the variation in some property of the medium which is also propagating through the medium. Broadly, we can classify waves into two categories. We have longitudinal waves and we have transverse waves. When we talk about waves, there is a very common toy found in almost every household called a slinky. And this toy is very useful to us because it allows us to visualize what these waves or these wave types actually look like. So here we have a slinky, we have held it at one end and we are rapidly jerking it up and down. As a result, a wave is traveling through the slinky toy all the way to the other side. So my question is, what exactly is changing? Well, if you look closely, the location of the point on the slinky is varying continuously. It is going up and down, and this change in the property of the medium. What is our medium? Our medium is the slinky toy. The property we are talking about is the position of these particles at any instant of time. This property is changing with time and also moving along the slinky toy from one point to the other. So this is a wave disturbance. Now, if you look at sound, sound is also a wave. Sound travels in the form of compressions and rarefactions. Compressions are the regions where the density of the air medium is increasing. Rarefactions are the regions where the density of the air is decreasing. In this case also, the disturbance in the medium, the change in the medium's property is pressure. The pressure is increasing in the compressions and decreasing in the rarefactions. And in addition, this disturbance in the property of the medium is traveling from the child to your ear. So this is also the example of a wave. Now, if we pay attention to the previous diagram for longitudinal and transverse waves, we notice that they have certain things in common. For example, both of these waves have the defined quantity of wavelength. Both of these waves have regions of high and low values for whatever property we are discussing. For example, in this case, the distance between the molecules or the coils in the spring is changing. Here, the value of the signal is increasing and decreasing around a certain mean position. So whether it is a longitudinal wave or a transverse wave, they will carry certain properties in common, which are common to all waves. Now, why is a longitudinal wave different from a transverse wave? Well, in this particular case, as you notice, the variation in the property is traveling in the same direction as the wave. So, the compression and rarefaction of the air particles of this medium is happening in the horizontal direction, but the wave itself is also traveling in the horizontal direction. This is the quality of a longitudinal wave. The disturbance in the medium travels in the same direction as the wave is traveling. Contrast this with a transverse wave. For example, look at the slinky again. When we jerk it up and down, the variation of the property, that is the location of the particles of the slinky toy, is in the perpendicular direction to the direction in which the wave is actually traveling. So, while the wave is traveling from me towards the wall, the actual movement of the particles is taking place up and down. So, it is perpendicular to the direction of the wave. This is an example of a transverse wave. On the other hand, if you were to give a sharp push to the slinky toy, you notice that this compression in the toy is traveling from my hand to the wall, and the compression is also happening in the same direction. This is an example of a longitudinal wave. Let's summarize what we have learned so far.
Manorama Horizon. Learning made simple.